Solution 1. No substitution. Use a property of fraction in the numerator. Combine rational expressions in the denominator. The square root of x squared leads to the absolute value of x. Meanwhile, the x squared is the same as the square of the absolute value of x. Divide out a common factor. Now, we are trying to find the integral of 1 divided by the product of the absolute value of x and the square root of quantity x squared minus 1 dx. Because of the factor the absolute value of x, which is defined as x if x is greater than or equal to 0, negative x if x is less than 0. The integral now consists of two cases. First, the integral of 1 divided by the product of x and the square root of quantity x squared minus 1 dx if x is greater than 1. Second, the negative of integral of 1 divided by the product of x and the square root of quantity x squared minus 1 dx if x is less than negative 1. These integrals are valid only over their respective inequalities because the function 1 over x times the square root of quantity x squared minus 1 is not defined between negative 1 and 1, which would have meant taking the square root of a negative number, or 0 making the denominator 0 too. Integrate the two cases using an inverse trigonometric function rule. The integral of 1 divided by the product of x and the square root of x squared minus 1 dx is equal to the inverse secant of the absolute value of x plus c. Accordingly, the first case is equal to the inverse secant of the absolute value of x plus c if x is greater than or equal to 1. The second case is equal to the negative inverse secant of the absolute value of x plus c if x is less than or equal to 1. Note that the inverse secant function is defined at x equals 1 and x equals negative 1. Hence these numbers are included in the domain of the indefinite integral. Notice that the two cases differ mainly by their signs. Consequently, they may be written as the inverse secant of the absolute value of x multiplied by 1. If x is greater than or equal to 1, -1. If x is less than or equal to -1, then add c. Now, consider the quotient of x and its absolute value. It is equal to 1 if x is greater than or equal to 1, or it is equal to -1 if x is less than or equal to -1. Therefore, the integral of 1 over x squared all over the square root of 1 minus 1 over x squared dx is equal to the inverse secant of absolute value of x times x divided by the absolute value of x plus c. Solution 2. Substitution rule. Rearrange the integrand such that a substitution rule can be applied. Use a property of fraction in the numerator. Multiply the integral by -1 twice, which does not alter the integral, so that a substitution rule can be applied. Notice that the factor 1 over x and its derivative, -1 over x squared, can be found in the integrand. Then, let u be equal to 1 over x. Du equals the negative of 1 divided by x squared dx. Now, we are trying to find the integral in terms of a new variable u. Apply an inverse trigonometric function rule. The integral of 1 over the square root of 1 minus u squared du equals the inverse sine of u plus c. The indefinite integral is now the negative inverse sine of u plus c. Substitute u equals 1 over x. Finally, the integral of 1 over x squared all over the square root of 1 minus 1 over x squared dx is equal to the negative inverse sine of 1 divided by x plus c. Conclusion. Proof of equivalence. If x is greater than or equal to 1, the answer of solution 1 is the inverse secant of x plus c. The inverse secant of x is equal to the inverse cosine of 1 over x. Convert inverse cosine to inverse sine. Hence, the inverse secant of x plus c is equal to the negative inverse sine of 1 over x plus c. Which is the answer of solution 2. If x is less than or equal to -1, the answer of solution 1 is the negative inverse secant of negative x plus c. The inverse secant of u is equal to the inverse cosine of 1 over u. Convert inverse cosine to inverse sine using these identities. Hence, the negative inverse secant of negative x plus c is equal to the negative inverse sine of 1 over x plus c. Which is the answer of solution 2. Thank you for watching. Please like this video and subscribe to Professor Reginald's channel to get the latest updates.